Example, solve the system of equations by graphing. We have two linear equations in the system. To find the solution by graphing, I'm going to graph both lines in this coordinate plane. Wherever the two lines intersect will be the solution to the system. I'll graph the first equation first. I'm going to turn this equation into the y equals mx plus b form. Okay, to leave this y by itself, I need to subtract 4x on both sides. So y equals negative 4x plus 2, where this negative 4 will be the slope, and this 2 will be the y-intercept. Okay, I'm going to graph the line now. So the y-intercept is 2, which is 2 on the y-axis. That's 1 point on the line. I'm going to use the slope, negative 4, to find the second line. So negative 4 can be seen as either negative 4 over 1 or 4 over negative 1. I'm going to see it as negative 4 over 1. That means the rise is negative 4 and the run is 1. So that means I will go down by 4. That's my rise. So 1, 2, 3, 4, and run by positive 1. That means going to the right by 1, finding my second point, connect these 2 points. Okay, I got the equation, I got the line of the first equation. Now let's graph the second equation. Negative 3x minus y equals negative 1. Again, I'm going to leave the y by itself. So here I will first add 3x on both sides. So what's left on the left side is negative y equals, write the x term first, 3x, then the number term the second, minus 1. Leave y by itself. That means divide each term by negative 1. So you have y equals negative 3x plus 1. This means your slope is negative 3. I will see it as negative 3 over 1 here. And the y-intercept is 0, 1. Okay, so I'm going to start graphing by putting the y-intercept, which is 0, 1. Okay, to find the second point, I will use the slope. Rise over run is negative 3 over 1. That means I will go down by 3 units. So 1, 2, 3. Run is 1. So go to the right by 1. I've reached the same point here. I'll connect the 2 points, and the red line is the line of the second equation. And you can see from the graph that the 2 lines are intersecting at this point. 1, negative 2. And this 1, negative 2 is the solution to the system. Now I want you to work on these 2 problems. Graph each system of equations into the coordinate plane, and then find the solution to each system. Pause the video now and work on these 2 problems. When you're done, click play and check your answers. Here are the answers. For B, first I turn both equations into the y equals mx plus b form, and then based on the y-intercept and the slope, I graphed both lines. And you can see from the graph that the 2 lines are parallel. And we know parallel lines will never intersect. That means this system of equations have no solution. We can say it's no solution. Sometimes we use this symbol to represent an empty set. That means it's a set with no element inside, so no solution. If you turn both equations to the y equals mx plus b in C, you can tell they are the same equation. So when you graph them, they're the same equation. That means every point on the line will be a solution. And you can tell there are infinitely many points on this line. There are infinitely many solutions. It's not that any ordered pair is a solution. It's any ordered pair on the line is a solution. And this is how the homework represents the solution. This means that the solution is an ordered pair x, y such that this ordered pair x, y satisfy the equation 3x plus y equals 2. In other words, any point on the line of 3x plus y equals 2 is a solution to the system. To sum up here, if you have two lines that they intersect at one point, that means you have one solution. And the solution is the point wherever they intersect. If you have two lines that are parallel, that means you have no solution because parallel lines do not intersect. And if you have two lines that are the same line, that means they're overlapping. Every point on the line is a solution, so you have infinitely many solutions. So every point on this line will be a solution.